Hello, Algebra 2. Let's get going. Unit 4, day 3. I'm not filling all that in. If you want to fill all that in, go right ahead. Here's what I will tell you though. You're going to want to have your perfect squares memorized up to 15. It helps. You don't have to have them memorized, but it helps. It makes what we're doing today a lot easier. We're factoring special cases. We've been factoring for a couple of classes now. Now we have some special cases here that we're going to be dealing with, and I'm going to show you some tips and tricks to make this a little bit easier. Now, if you have your perfect squares memorized up to 15, it makes noticing how to solve this problem much easier. I'm aware that 121 is a perfect square, that x squared is also a perfect square, and 64 is a perfect square, separated by a minus sign. Now, something that we went over at some point is a quadratic consists of an a and a b and a c. Well, we have an A term and we have a C term, but we do not have a B. If you notice that pattern, we have an A, we have a C, they're both perfect squares, and it's separated by a minus. Go ahead and set up two sets of parentheses. Give them different signs. And now, in these two spaces right here is going to go the exact same thing. And the way that you find what goes there is you take the square root of the very first term here. The square root of 121 is 11, and the square root of x squared is x. Now to fill in these spaces here, we're going to take the square root of term C, the very last term, and the square root of 64 is 8. Over here, we're dealing with a perfect square trinomial. If you'll notice, term A, perfect square, term B, perfect square. Go ahead and set up your two parentheses. Now, in order to factor a perfect square trinomial, well, term A and term C have to be perfect squares. This also has to be positive, must be positive. And it doesn't matter what that sign is, but that sign is important. That means both of these are going to be minus. Now, had these been perfect squares and that had been plus, and that had been plus, then these both would have been plus. Okay, now to fill in these first two spaces, take the square root of term A. Now to fill in these two spaces here, take the square root of C. And you might be asking yourself, what about B? What do we do about that? Listen, try not to overthink this. If you want to see, did we get the right answer? Just FOIL all this out and combine the like terms, and I assure you, it's there. All right, example C. Perfect square, term A. Perfect square, term C, separated by a minus. This is a difference of perfect squares. To fill in these two spaces, take the square root of term A. To fill in these two spaces, take the square root of term C. Done. Example D, looks like we have something that we can factor out first. Looks like we can factor out a 3. I'm going to factor out a 3. Open up a set of parentheses. And in order to fill in these parentheses, divide the original problem by 3. 75b squared divided by 3. 25b squared minus 27 divided by 3 is 9. Now, if you look in the parentheses, we have a difference of perfect squares, so we can factor again. 3 stays on the outside in front. Different sign. We're now going to fill in these two spaces right here by taking the square root of that term. 5b. And now we're going to fill in these two spaces by taking the square root of this term. The square root of 9 is 3. Looking at example E, they do not have that set up in the correct order, so let's rearrange it. Term A first. There is no term B. Then we go with term C. Remember, if your leading coefficient is negative, you need to factor out the negative. Now, looking in parentheses, we have a difference of perfect squares. Set up your two parentheses, give them different signs. To fill in these two spaces right here, take the square root of that. And now to fill in these two spaces here, take the square root of this. That's your answer for that one. Example F, term A, perfect square. Term C, perfect square separated by a minus. Two parentheses, different signs. Take the square root of the first term, put the result in the front of each parenthesis. Then take the square root of the second term and put that result at the end of both parentheses. Here we have a perfect square trinomial. Perfect square term A, perfect square term C, and that's positive. Two sets of parentheses. If it's a perfect square trinomial, they're going to have the exact same signs. And it's this right here that tells you what those signs are going to be. Since that was positive, these are both going to be positive. To fill in the very front of these parentheses here, take the square root of term A. Then to fill in the back of these parentheses, take the square root of term C. Now there's a way of simplifying that. We have two parentheses that are exactly the same. I didn't show you this a little bit earlier, shame on me. This is a more simplified version right there. Here, perfect square term A, perfect square term C. Now this is a trinomial. Right there, we have a positive. So this is special factoring. This time, both these signs are going to be minus. And to fill in these two blanks, take the square root of that. And to fill in these two blanks, take the square root of that. But remember, this can be simplified. All right, let's go on to the next side. Complex numbers, imaginary numbers. Imaginary numbers means in a quadratic, we took the square root of a number that's negative. You can't take the square root of a number that's negative, but darn it, in Algebra 2, we figured out a way how to show some work, even though that's the case. You're going to want to have these memorized. You're going to want to have these memorized. You're going to want to have those memorized. Okay. And here's why you want to have them memorized. Well, if they tell you to simplify I to the fifth, notice that is not in our chart. Here's how you would solve for I to the fifth. I to the fifth. You're going to take whatever the exponent is, and we're going to divide it by 4. Why 4? Because there's 1, 2, 3, 4 possible answers that this could reduce to. You're always going to divide that exponent by 4. Well, 4 goes into 5 one time. 5 minus 4 is 1. So we would have 1 with the remainder of 1. Whatever the remainder is, that's your new exponent. And I to the first power is I. So I to the fifth is the same thing as I. Now, crystal clear, right? That's what I thought. I to the sixth power. We're going to take that exponent and divide it by 4. Why 4? Because there's 1, 2, 3, 4 possible options that it could be. 6, 4 goes into 6 one time. 6 minus 4 is 2, so that would be 1 with the remainder of 2. Whatever the remainder is the new exponent, and according to our chart here, I squared is the exact same thing as -1. And then so on and so on. Let's not do I to the seventh because I bet you can probably figure out what that's going to be without us having even done it. It'd be negative I, by the way. All right, what about I to the 62nd power? Ooh. I to the 62nd power. Let's take that exponent, 62, divided by 4. Now, how many times does 4 go into 62? I don't know, but I know how many times 4 goes into 6. Once. 6 minus 4 is 2. Bring down the 2. Now, that's a little bit more manageable. 4 goes into 22 5 times. 5 times 4 is 20. Looks like we would have a remainder of 2. So I to the 62nd power is the exact same thing as I squared. And according to your chart here, I squared is the exact same thing as -1. I to the 24th power. This is the last one we're going to end on. These negative powers here, I don't want you to worry about those for now. We might go over that over a review day, but for right now, let's just worry about positive powers. Okay, I to the 24th power. Let's take that exponent, divide it by 4. Well, 4 goes into 24 perfectly. 6 times. No remainder. So I to the 24th power is the same thing as I to the 0 power. And ladies and gentlemen, boys and girls, anything to the 0 power is 1. So your answer here is 1. I to the 0 power, 1. Looking at example 1. If you know what the square root of 81 is, then finding the square root of -81 is almost as simple. The square root of 81 is 9. And the square root of -81 is 9i. Remember, because you can't take the square root of a negative number, that's why imaginary numbers are a thing. So if you take the square root of a negative number, make sure you have I in your answer there. So our answer here is 9i. I want to do example 3 now because it's pretty similar to 1. The square root of 16, positive 16 is 4, but the square root of -16 is 4i. You see how easy that is? Look right here. Look at 5 now. Well, the square root of 7 can't reduce. It can't. It's just the square root of 7. But the square root of -7 would reduce to this I root 7. Just make the inside positive and put an I on the outside. That's how you simplify those. Well, what about example 2? Well, I don't like that negative inside the root there, so let me fix that. Let me change it to I square root 27. Now, this can be reduced. We learned this day 1, and I think we did some of that day 2 also. You're looking for pairs and anything left over. This reduces to 3 root 3, but don't forget we had an I there in the front. So it's really 3i root 3. Okay, example 4. I don't like that negative inside that root. So let me simplify that first. Okay, we have I root 18x squared. Let's simplify this. Pair left over. And here's what we have so far. Anything that's circled goes to the outside. Don't forget we had an I on the outside. Anything that's underlined goes back in. And now what about that x squared? Well, x squared is the same thing as x times x. Hey, there's a pair. Anything you have circled goes on the outside of the root, and whatever's left over goes back in. Well, there's nothing left over here with these x's, so there's no more x inside the root. That's your final answer. Oops. All right, example 6. I'm going to start by writing the negative that they have here. I don't like that there's that negative inside the root, so let me go ahead and fix that now. Put an I in front. 32x, y, 6. And now let's reduce what we have left over. 2 goes into 32 16 times. Ding, 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 ding. And this is where knowing your perfect squares come in handy. 16 is a perfect square. If you're simplifying these and you see a perfect square, you've hit the jackpot. The square root of 16 is 4. If you have matching numbers here, you stop, you're done, don't do anymore. So here's what we have so far. We have negative 4i square root 2, the 2's left over, x, y to the 6th. Well, the square root of 2 will not reduce anymore. The square root of x will not reduce anymore. But the square root of y will, or y to the 6th power, the square root of y to the 6th power will. Watch this. Y to the 6th power is the same thing as this. Y times y times y times y times y times y. And we're looking for pairs, aren't we? There's a pair. There's a pair. There's a pair. So I'm going to sort of expand this a little bit so that hopefully it sticks a little bit more. Let me rewrite what my answer is. Negative 4i. How many circles do I have? 3. Y times y times y square root 2x. The only thing we have remaining in that square root is 2x. And if you multiply all those y's together, you get negative 4 y squared I root 2x. That's your final answer. You remember that chart at the top right of this page that we're currently on? Is it this page? Yeah, it's this page where there's I squared, I cubed, and I to the 4th. You want to commit those to memory, but you really want to commit to memory I squared because we're going to be seeing I squared a lot. And whenever we see I squared, we need to change it to something. I squared is the same thing as negative 1. So we can simplify this problem here. Rather than 3 times I squared, it's 3 times negative 1. And 3 times negative 1 is negative 3. That's your answer. Okay, here, square root of negative 24. I don't like that negative inside the root, so I'm going to fix it. And now let's reduce. Pair left over. So here's what we have. We have that circle there. So let me remove a 2. 2i root. Whatever's underlined goes back inside the root. And then multiply those numbers. 2i root 6. 6. I don't remember what goes here, but it's on my answer key. So look at the answer key. Which of the following pairs are complex conjugate? This one. Not that one. This one. Complex conjugate simply means locate the I and then make sure the other I is opposite of that symbol. So this was positive I. This one has to be negative I. Notice the 3's didn't change. Do not change those. So the complex conjugate of, let's just say 2 plus I is 2 minus I. Here, they flipped the wrong thing. They have negative 5 here and positive 5. Well, neither one of those have I in them, so we don't need to change those signs. You don't want to change those signs. Here, 2I is exactly the same. You don't want that. Here, 2I and its complex conjugate is negative 2I. You just flip the sign in front of the term that has I. So here, now you give the complex conjugate of each. 7 minus 4i, the complex conjugate is 7 plus 4i. That's it. Here, 6 plus 5i. Therefore, the complex conjugate is 6 minus 5i. This will make a little bit more sense of what we're doing in a little bit later. Operations with complex numbers. Example F. Let me start rewriting this. 7. Now distribute the negative throughout the parentheses. Negative times 10, negative times 2i. Okay, and now we're just combining like terms, y'all. 7 minus 10 is negative 3. Negative 2i minus 5i is negative 7i. And you're going to leave your answer just like this. All right, here, let's see. Let me start rewriting some stuff. 5 minus I minus 6i. Distribute that negative throughout the parentheses. Okay, now let me clean this up a bit. I got kind of a lot going on here. I'm gonna group. See, I just rearranged things. That's all I did. Makes it a little bit easier to simplify. At least for me, it does. 5 minus 8 is negative 3. Negative I minus 6i is negative 7i. Let me carry down the plus 2i. And now combine those. Negative 7i plus 2i is negative 5i. That's it. That's all you got to do for that one. Example H. We've gone. Sorry. We have to FOIL. Let's do it. Negative 4 times 2 is negative 8. Negative 4 times negative 5i is positive 20i. 3i times 2, 6i. Now be careful with this one. 3i times negative 5i is negative 15i squared. Now let's do some simplifying. Negative 8. 20i plus 6i is 26i minus 15 times negative 1. Because remember, I squared is really negative 1. Let's simplify a little bit more. Negative 15 times negative 1 is positive 15. And now we can combine these like terms right here. Negative 8 plus 15 is 7 plus 26i. That's your final answer. Example I, please remember, anything that you're squaring means you have two of the exact same thing. Those are 2's, not z's. Now we FOIL. 6 times 6. 6 times negative 2i. 2i, negative 2i times 6. Negative 2i times negative 2i is positive 4i squared. And now let's simplify. Remember, I squared is really negative 1. And now we can combine these like terms here, the 36 and the minus 4. Final answer. Okay, let's do example J. This one's got a lot of stuff going on. Proceed with caution. In fact, I'm going to rewrite it again because even I'm a little nervous. -3 or minus root -3. Okay, well, I don't like that those roots are negative. So let me fix that. I root 3. Okay, now let's start foiling. 2 times 4. 2 times negative I root 3. Now here, negative I root 3 times 4. And now here, negative I root 3 times negative I root 3. Well, first of all, that's going to be a positive. I times I is I squared. And root 3 times root 3 is the square root of 9. Okay, now let's do some simplifying here. 8. Let's combine these like terms. Minus 6I root 3 plus I squared is really negative 1, and the square root of 9 is 3. We can simplify just a little bit more. Negative 1 times 3 is negative 3. And now the last bit of simplifying. 8 minus 3 is 5. Thank goodness. Have a good day.